Today I'll run through a bit of background about Whitehaven, a bit of background about our program, and then dive into the detail of some of the control improvement initiatives that we're embarking on, and diagnostic activities and those types of things, and hopefully share some learnings that you can take back to your operations. So a bit about Whitehaven Coal. We are largely based in the Gunnedah-Narrabri region of northwest New South Wales. Got about 1,400 employees across our various operations and an equivalent number of contract FTEs as well, so and building that workforce. We've got one underground mine at Narrabri, which Justin used to work at, and we have Maules Creek Coal, Tarrawonga are our two larger open cut operations. Werris Creek Coal is progressing to closure, so it's wrapping up in the next couple of months. But we've fortunately we've started early works at Vickery Mine, so a lot of the Werris Creek workforce have fortunately been able to retain employment and just move across to a different operation, which is a good news story. So moving on. Today I'll cover off on the background, as I mentioned, key initiatives, hygiene risk assurance, pairwise silica monitoring, dust improvements at Narrabri, HEPA filtration at Maules Creek, and give a little bit of detail on a diagnostic activity we did at diesel particulate matter earlier in the year. So a bit of background. In 2015, way back when I started with Whitehaven, we identified that we needed to expand our hygiene monitoring program beyond basically meeting the basic statutory requirements. So it was a bit all over the place, and we were really just compliance driven. Jumping forward 5 years, when the exposure standard for silica reduced to 0.05, we acknowledged that we needed to have an even greater focus was required on the identification, management and control of airborne contaminants at our operations. And more recently, we acknowledged that we need to be proactive and engage in a greater depth of assessment to identify and assess our areas of improvement. Summary of our SEG program. So essentially, this was born out of the review we did in 2015, and we collaborated with Coal Services and created our own SEGs, not just the industry SEGs, and started our SEG monitoring program. The initial program was based on getting enough numbers to achieve statistical significance over a 3-year period, and now that's a rolling kind of thing. We just use the progressive 3 years of data for our risk profiles for our SEGs, which has put us in a pretty good position now that, as a result of the MEMSS report into the health surveillance scheme, or Order 43, we have a lot of confidence in our SEG risk profiles, which helps us accommodate or not accommodate the dust restrictions that are starting to be seen on medicals for workers that have identified respiratory issues. And the data set we've got to date, we've got probably nearly 7,000 samples have been taken over the last 8 years in our SEG program, and we've had at least 750 of those samples are just for dust on our longwall at Narrabri. So a pretty comprehensive program that gives us a lot of statistical confidence in our risk profiles. And as you can see there, we've expanded the program over the years, constantly reviewing it, adding in different SEGs. Some examples there are domestic cleaners, exploration drillers and coal haulage operators. We actually have had some exceedances in our domestic cleaners, sweeping airborne dust on the verandas, and as a result they're not allowed to sweep anymore. They have to hose down all the verandas, and we haven't had any subsequent exceedances since then. So it's just areas beyond just our traditional mining activities where we identify there are problems. Key initiatives that I'll talk through are our risk and assurance program, paired silica monitoring, continued longwall automation implementation, HEPA system at Maules Creek and implementation for all mobile plant, recent diagnostic review of DPM, and then introduction of real-time monitoring for respirable coal dust. Some other initiatives that we've achieved over the years is we were able to make any dust control in our open cut plant and equipment values are category A defects, so on the maintenance schedule, so that's both at intro to site and from the inspection programs. We established safe standing zones underground at Narrabri, did that a fair while ago. Authority to spray, stoppings reduced at Narrabri for the control of inhalable dust, particularly with grout spraying. company-wide personal dust awareness sessions. So we've had Mark Shepherd's come out numerous times to Gunnedah and delivered to a few thousand people the dust awareness training, and we'll continue that. And we introduced the ILO chest X-rays before they were part of the Order 43 for the entire workforce, not just the underground workers, again back in 2017 or 18. Performance improvement. So this slide here really shows how we have improved our silica exposures over the years for the past 3 years. So back in the bottom line, back in 2021, we had a 12% exceedance rate for our silica personal exposures. And this year to date was, as of the end of July, was just under 3% exceedance rate for silica. So we are obviously trying different things all the time to bring those exposures further down. But it's a 69% improvement from 2021 and 22, and then a further 28% improvement year to date. Hygiene risk assurance. So essentially this is our critical control monitoring program, which involved the application of our risk management framework to develop the CCM program for airborne contaminants. And that includes dust and diesel particulate matter. And the process was followed. It was started with a level 2 broad brush risk assessment, progressing to bow tie risk assessments to identify the significant or important controls, and then we essentially filtered them through the ICMM model to really pull out the critical controls and inform the program. And commenced in late 2021, we commenced the assurance program relating to airborne contaminants, which was providing us more confidence in the management of our HSE risks relating to dust control and management. First hygiene audit has only recently been completed. It was an external audit. We engaged GCG to do that body of work, and really diving into our alignment with legislation and our internal governance requirements. So reports are still forthcoming for that. So it'll be interesting to see where we can go next. Real-time paired silica monitoring. So this is probably the project that I'm personally most excited about. So to find out what we can actually uncover or discover across our operations, and also verify what we are doing well. So the impetus to do paired silica monitoring for specific tasks is obviously with the upcoming exposure standard change to fluorospirable crystalline silica. So it's going to halve again from 0.05 milligrams per cubic metre to 0.025 with a 3-year phasing period. So we're expecting that to occur in 2026. So this graph here really just demonstrates the impact of that exposure standard change on our existing data set. So the dark blue line is the exceedance rate with the current exposure standard of 0.05. The lighter blue line is the hypothetical scenario if we applied the 0.025 level to the same data. So probably the most polarising situation is the current year, 2023, obviously, where we've got pretty good, like 2.9% exceedance rate currently, but that would blow out to nearly 26% with the application of 0.025. So it's a bit of a problem. Obviously, we don't want to have exceedance events, and with that, we've got timeline 5Y investigations at a minimum. We've got notifiable events to the regulator, repeat sampling, and with that there's a risk of having more exceedances and those types of things. And obviously if there's a pattern there, obviously we could have regulatory action, which we all want to avoid. So why are we doing paired silica monitoring? It's to understand our real-time silica exposures for specific tasks, to identify the tasks that are really contributing to our exceedance events, and also to verify the effectiveness of some controls that we have implemented. What are we doing? We're assessing real-time silica exposures, as mentioned. How? We're engaging with GCG again, consultant hygienists, using it's a paired methodology, so they'll use the standard personal dust pump, but at a higher flow rate. It's 4.4 litres per minute, so they can draw in more air in shorter sample periods, so therefore you can do task-based monitoring. And the limit of detection is also lower, so you've got more statistical confidence with the results. And simultaneously, the worker will wear the AM520 real-time gravimetric pump, and together you'll get the representative data of what's actually happening, the exposures in real time for specific tasks, activities, processes that we've identified. And where are we doing it? We're doing it across all of our operations. So we've got the hygienists coming out for a fortnight in early November, so in a couple of weeks' time. And they're spending an entire week at Narrabri, and we'll split them across our open cut operations for the surface-based tasks. The anticipated benefits that we're hoping to achieve from doing the real-time monitoring for silica is obviously we'll develop our own library of tasks, processes, work areas that are contributing to our exceedances for silica. Target control initiatives even further, so we can try and get ahead of that exposure standard change and not have significant number of exceedances when that does come in. Future-proof for control, implementation and verification. So that's quite relevant as we are building a new mine with Vickery. So obviously be bringing a lot of new plant and equipment to site, which is quite exciting. Education of our workforce for exposure control. So the bit I failed to mention was we will, where possible, the worker will also wear a GoPro so you can get the visual footage of the dust that marries up with the data in real time, which can be quite powerful messaging for the workforce in terms of changing process or really that effectiveness of a control. Estimate allowable times for task rotation, so providing some science behind you can only do this task for 2 hours and you have to move on, for example. It's a real opportunity for innovation. So the paired monitoring methodology is not new. It's been utilised in British Columbia and through Europe for a number of years. Australia is just a late adopter, and essentially we've got an opportunity to really jump on and do something innovative that hopefully can become the norm across industry. And lastly, there's an opportunity to build the paired monitoring into our investigation processes following an exceedance event. But to do that, we would probably need to develop some internal capability because hygienists aren't really available readily on call. So moving on to some specific activities that are happening at Narrabri, or have happened at Narrabri. First one is longwall improvements. So Narrabri are in the process of implementing a remote shearer for longwall 203, which obviously was discussed in Yolanda's presentation this morning. And they currently run on a high level of automation, and the operating systems rely on the shearer operators, observing the shearer functionality. And they generally operate at 90% no operator input to the shearer. They've commenced the transition to remote management over an 8-week period, which commenced in September, and it's ongoing at the moment. And obviously the major benefit of the remote operation up on the surface is you're removing the majority of the shearer operators when it's cutting, and therefore removing them from the dust exposures. Other benefits is other hazards such as fly rock, so we'll reduce injuries as well. We've also installed a new scrubber unit at the BSL at Narrabri, and this is one of the controls that we're going to verify when we do the paired silica monitoring next month. So we're going to do a few scenarios with both of the scrubbers activated, one of them on, one of them off, and then neither of them on, and demonstrate the effectiveness of them removing the dust from the area at the source. Other controls, additional sprays have been installed at the BSL entrance, and more recently they've put some sprays on the rear walkway of the longwall. That's just very recent, it's only just been installed, and we're kind of working through how effective that will be. So we'll also include that in our paired monitoring program for some control verification. In August, we re-established our dust and DPM committee at Narrabri. So that's led by the workforce, and the workers are really passionate, coming up with the ideas and solutions to try and improve how we can manage dust and DPM exposures at Narrabri. And they're installing and upgrading to EnviroMist at the continuous miner, and obviously the benefits there are changing the water delivery pressure and nozzle combinations to better control the particle size of the water droplets to better capture the dust and suppress it. Now we'll dive into the HEPA filtration project at Maules Creek Coal. So it was back in 2020, the maintenance team at Maules Creek identified that they needed to do something to control the dust exposures for our drillers. And the 3 problems that they were able to unpack were, or the sources of the dust ingress were the structural integrity of the cabin, cab pressurising systems, and build up of fine material on the deck and entrance. So anyone that's been on a drill would be quite familiar with those 3 scenarios. So the first problem was cab filtration and pressurisation capabilities. What was the solution? Well, Maules Creek partnered with a local contract partner, GB Autos, and installed BreatheSafe HEPA filtration units in all of the drills, and were able to make a significant difference on the personal dust exposures, which I'll show you in a moment. This slide here just shows the unit on the outside, so it's that silver box, so it doesn't have a very big footprint, which is good. And it's the gold standard of filtration, cabin filtration on mobile plant. And that's the image of what it looks like on the inside, so it's obviously the little kind of cream box. The next problem was the operators walking dust in and out of the cabin. Obviously, drillers are in and out of the cabin quite often, and more dust that's built up on the platform, the more dust that gets into the cabin in the first place. So what was the solution? Was design and fit out high flow washdown area to create extra water carrying capacity on the drills. Therefore, the operators are able to hose their platforms down more regularly, and resulting in less dust being walked in and out of their cabins. That just shows the unit, or the before and after. So this is obviously when they've cleaned. So this is some real-time monitoring we did. It's just coal dust, not silica. We'll do some silica monitoring next month when we've got GCG out on site. But the results are polarising. So the graph, the blue line, is a drill that wasn't yet retrofitted with the HEPA filtration system and the water hose, like the hose down mechanism. And the drill on the right had been completely retrofitted. And so you can see the area under the curve on the blue side is quite high. So there's significant exposures in the, before, and the really effective control. So Maules Creek have embarked on a program where they've retrofitted the units in all of their mobile plant and equipment, all but the excavators and the EH5000s. And they're all scheduled for financial year 24. So by the end of this current financial year, all of the mobile plant at Maules Creek will be fitted with the HEPA filtration units. And we've had success with, again, having a really good opportunity with building a new mine. The equipment specifications for the mobile plant and equipment at Vickery is to include HEPA filtration systems at the point of procurement. And lastly, I'll talk about our diesel particulate matter diagnostic activity that we did earlier in the year. Again, we partnered with GCG to do this activity for us. And so essentially it was an assessment of our management practices around DPM exposures at Narrabri. So we could understand the level of maturity of our management and control of DPM mapped to they kind of developed just a customised, we call it an audit tool, but a diagnostic tool that was largely mapped to the ICMM DPM maturity framework. And it was to provide Whitehaven with a holistic assessment of our opportunities to improve how we manage and control DPM and reduce our personal work exposures. That's just a slide of what the ICMM framework looks like. Obviously, I don't expect you to be able to read it. But the key categories are we were assessed in areas of ventilation circuits, supportive infrastructure, fleet management, exposure monitoring, DPM production at the source, or at the engine, DPM emission reduced at the tailpipe, and DPM exposure reduced at the operator. So it was all those categories that we're assessed in. And essentially you get a score for where you are now, and then what your desired state is, and some recommendations from that. And the drivers for the recommendations were wanting to, see what we have a look at where our gaps are so that we can do better. And as I mentioned, based on the ICMM criteria. And what capabilities we're going to require to achieve best practice or working towards that anyway. And just to close off, some DPM initiatives that Narrabri have already kind of implemented or in the process of they're implementing the automated real-time diesel tag boards with log-on facilities using the MST tracker. And they're actively reviewing filter technologies, such as looking at Tier 4 filters, moving away from, I think they're using Tier 2 at the moment, and reviewing the DPM sampling. We're reviewing our sampling program for 2024 to see if we need to do more to get more confidence with our statistics, because we've got lots and lots of dust data that we're comfortable with, our DPM data set isn't as high, so it is something that we can probably improve. Thank you.